This is the first lesson of Unit 4, and Unit 4 is all about solving equations, so we're going to learn to solve different kinds of equations. But we're going to start this unit, a lot like we did the last one, with a little activity, and the point of this activity is for you to just kind of figure out these answers however you like. So there are no proper steps or proper methods to show your work or anything like that. You are just going to try to figure out the answer on your own, kind of thing. Okay, so throughout this activity, I would encourage you to pause the video. I will hesitate for a moment, but not for too long. So if you do need a bit more time to answer these questions, pause the video, see if you can come up with an answer. Don't take too long. We don't want this activity to take too long. And if you can figure it out, great. Then start watching the video again and make sure you got it right. And if you can't, that's okay. And just move on to the next question. And then after that, we're going to do a lesson and start talking about some other strategies as well, just like we did in the last unit. So, variables. What are variables? Well, we're not going to worry about that yet. We're just going to say what number is in the square, what number would make that equation true. And you probably came up with the answer of 2, because 2 plus 3 is 5, right? Very good. And again, very quickly, this is something that you have definitely talked about in elementary school. Even back as far as grade 2, they start introducing the idea of sort of a balanced equation. They don't talk about solving equations, but they do use it for looking at things like adding and subtracting, those ideas. But the point of this is when you have an equal sign and you have two sides, the left side and the right side, they always have to be balanced. So there's only one number that can go in that box to make the two sides balance. If the right side is 5, the left side also has to be 5. So it's got to be a 2, because 2 plus 3 is 5. Okay, here's another one. Again, try it yourself. And hopefully you came up with 10. 10 minus 4 is 6. This one's a bit different. So it's multiplying, and it's saying some number multiplied by 2 gives you 8. What is that number? And hopefully you came up with 4. So we are going to talk about strategies to calculate this. Let's say the numbers were really big, or just numbers that you're not familiar with, or decimals, not friendly numbers. Or if you're not great at your times tables and you don't have your times tables memorized really well up to a big number, it might be hard for you to figure that out. So we are going to talk about strategies for that. But if you have a multiplication table, like a chart, that can be really helpful for this kind of thing. We're going to learn some strategies so that you could use your calculator as well. But that'll come later. So then the question is, what if I'm not good at drawing shapes? Or what if drawing shapes is kind of awkward and slow? And so in math, it's a standard that we use variables. We use letters instead of shapes, okay, to represent unknowns, to represent things we're looking for, things we're trying to find, things that we don't know. And it's actually also the same as just having a question mark. Something plus 4 is 9, right? That's all a variable is. And people kind of joke about math and how they're always trying to find x and what is the obsession with this x. But really, it's something we don't know, and we want to know what it is. And so variables, whatever letter we use, is just a placeholder. It's just a question mark. What goes here? Right? So what is the answer to this one? You probably already figured it out while I was talking. And so it should be 5. Again, if I get rid of the A and if I thought of it as a box, I would put 5 in there. 5 plus 4 is 9. But something really important to know is that when we have variables, our answer will actually look like this. We're going to say what A equals. So instead of just, writing a 5 on top of it or something like that, we're going to say A equals 5. That's what our answer should look like. So again, try all these on your own. First of all, you have to understand what this one's asking. It means 3 times something gives you 12. And what is that something? Again, if you know your times tables well, then that might just jump out at you and you might already know the answer. If you don't, it might take you a bit longer. In this case, B is 4. 3 times 4 gives you 12. Okay, if you didn't know that, you could try things. 3 times 2. Nope, that didn't work. 3 times 3. Nope, that didn't work. 3 times 4. Okay, that gave me 12. So you could try different things like that, but that's pretty slow. So we're going to try to come up with a better way of doing it. But in a pinch, sometimes we do guess and check like that. So this one says something divided by 3 is 2. So you should get C equals 6. 6 divided by 3 gives you 2. Again, maybe you have no idea where to start and you say, well, I'll try 30 divided by 3. And that's 10. So we need to go smaller. So maybe you cut it in half. Well, we got a lot closer, but we're still not there. Then maybe you go 10 divided by 3 and you get a decimal, but you're closer, right? And you might just keep working your way closer. But again, that's a slow way of doing it. So what is D in this case? What makes it balanced? What value could I replace D with to make this work? 11. 11 minus 4 is 7. Ooh, this one's a bit different. What does it mean E plus E? It means some number plus itself, because E has to be the same. So something plus itself is 12. And again, this is what's interesting, is a lot of people have really good intuition and you know the answer to this really quickly. And it's interesting that you can figure this out, but then when we start to ask you to do it sort of the math class way and think about algebra and think about solving equations, then people start to say, oh, I don't like this kind of math. But it really is the same thing, just with a little bit more structure in how we show our work. But that intuition that you have, so if you said E is 6, very good. 6 plus 6 is 12, and a lot of people will know that automatically. Now, if we go back to the last unit, you don't have to do this, but it's just interesting to sort of connect these ideas. What is E plus E? We talked about that in the algebra unit, in unit 3. It's 2E. So 2 times some number is 12. And again, 2 times 6 is 12, right? So all of this stuff makes sense. All of these ideas fit together. And it can be useful to notice that and make those connections. And it can be helpful to sort of see how all the pieces fit. Okay, let's keep going. We got a bunch more to do. Maybe we'll run through some of these a bit more quickly. Again, this one's interesting. The last one was something plus itself. This one is something minus itself. And so usually when we do this in class together, we get a whole bunch of people giving different ideas. So we might get F equals 1. 1 minus 1 is 0. Or F equals 10. 10 minus 10 is 0. Or F equals a million. A million minus a million is 0. So f could actually be anything in this case. F could even be a negative number. Maybe somebody thought of that. Negative 5. Anything subtracting itself will give you 0. What if the equation was this? F minus f equals 1. Can you take something and subtract itself and get 1? No, so that question wouldn't have an answer. So try this one. Again, always pause the video. I'm going to go a bit faster, so pause the video if you have to. So this one's weird because it's 10 plus something gives you 6. And how can you add something to 10 and get a smaller value? But often there is somebody in the room who recognizes that it's a negative number. If you add a negative number, you'll get smaller, right? And 10 minus 4 is 6. And again, if you go back to when we talked about integers, 10 plus negative 4, right? You use that rule to do 10 minus 4. A positive and a negative make a negative. And that gives you 6. So it still works and it still fits with the other ideas that we've learned already. So this one is similar. I'm supposed to be adding something to 9, but I get a smaller value. And so in other words, I actually need to be subtracting. And 9 minus 5 gives you 4, so I want to add negative 5, which would be the same as subtracting 5. Okay, again, I'm adding two things, and not only am I getting smaller, but I'm going into the negatives. And again, this is where we start to see that our intuition, and we're going to talk about this a lot more, but our intuition is great when it works, but when it doesn't work, and people say, oh, the numbers just jump in my head, like I can just see the answer. That's great when that works, but what happens when that doesn't work? What happens when it's too hard for that? The questions are too long, and even if that doesn't happen in grade 9, what if you end up in calculus someday? Those answers are not just going to pop into your head. So we need a method, a system that we can solve these questions, a different system where we're not using just our intuition, just whatever number jumps in our head. And if that's the case for you on a question like this, that's fine. You don't have to be able to solve these in your head. But then you have to focus on the strategy when we learn it for how you're going to solve these kinds of questions. But if it does jump in your head, that's good because it does make it easier. And the answer for this one should be negative 5. So negative 5 plus 2 gives you negative 3. 3 times something equals 6. Nothing strange about this one. It's just 2. 3 times 2 is 6. Now we see why that question was there. So now it's 3 times something is negative 6. So what does it have to be? Well, it would have to be negative 2, wouldn't it? So the 2 stays the same. 3 times 2 is still 6, but if we want that negative in there, then we have to have a negative, because positive times a negative gives you a negative. Something divided by 5 gives you negative 3. So what is n? So 15 divided by 5 gives you 3. But again, I need my answer to be negative. So it's going to be negative 15. Again, you can check all these on your calculator. Negative 15 divided by 5, negative 3. Six times something is negative 18. So 6 times 3 is 18, so we want negative 3. 4 plus 6 is 10. Nothing weird about that one. What do I add to 8 to get 0? So this one should be -8, right? So I'm starting with a -2. Okay, so let's take a look at a number line just quickly. And you can pause and solve this question if you want, but I'm starting at -2, and I need to end up at 6. So what do I have to add to -2 to get to 6? Well, I've got to add 2 to get to 0, and then 6 to get to 6. And if I add 2 and I add 6, I'm adding 8. So t has to be 8. -2 plus 8 is 6. And again, even if you can do this in your head, and visualizing it on a number line that way is really, really useful. It really helps us make sense of these questions. But in the end, we're going to come up with a strategy where you can just do this on your calculator, and that's often the quickest method. Something minus 1 is -1. Some of these are going to be a little bit trickier. So again, I'll just encourage you to take a moment to think about it yourself. This one's 0. And I think that's the last one. We're not going to do any more of these that have multiple parts to them. So we're going to stop there, and we're going to jump over to the other part of this lesson where we talk about strategies. Okay, and I'm going to dive right into it. So as we already said, an equation is always balanced. That's what the equal sign means. Okay, it means both sides are balanced. And now here's where it's kind of interesting. If you were very good at that activity and you were coming up with those answers very quickly, and if you like to do math that way, you like to just think of the answer and write it down, then that activity might have gone very well for you. However, as soon as we look at something like this, and I'm not saying you can't do this question in your head, but I'm saying it's a lot harder to do a question like this in your head. And I would say that generally speaking, the answer's not just going to jump out at people, okay? The way that it was in those other cases, the answer was almost screaming at you. That's not the case for a question like this. And in fact, this question is designed this way on purpose, where it doesn't have a nice answer. It's not just 2 or 3 or 4. The answer ends up being a fraction. So and that's something that we have to deal with in the real world. Often our answers are fractions or decimals. Okay, so so this is just a reminder that we do need to have other strategies that can solve it. So we're not going to solve that kind of an equation yet, although we will a little bit later, and that in grade 10, the questions will get even harder. And so using these strategies will be really important. So because an equation is balanced, we have to maintain that balance, right? We have to keep it balanced. And this is probably something you've heard before. That means whatever you do to one side, you have to do the same to the other. If you think about a scale, right, that's balanced, and you've got 5 pounds on both sides, or that's a lot, maybe 5 grams is easier to think about. If I add 3 grams to one side, I would have to add 3 grams to the other side to keep it balanced. If I double the weight on one side, I'll have to double the weight on the other side to keep it balanced. And, I might have one 5-gram weight on one side and a 2-gram weight and a 3-gram weight on the other. Right? But in both cases, it's 5 grams or 5 pounds or 5 kilograms or whatever you want to say. So if I double this, I have to double that. Or if I add 1 more to this, I would have to add 1 more to that. And now they're both 7. I added 2 pounds. Now they're both 7, right? And that's what that means. So that example can be a good thing to be thinking about while you're doing these questions. Oh yeah, I always have to keep it balanced like a scale. And so whatever I do to one side, I have to do the same to the other side. Now, the last thing we're going to talk about before we get in here, and this won't be a huge part of today, but in the future it will. What does it mean to solve an equation? Well, solving an equation means finding the value of the variable that makes it true. So we've already talked about that. But another way of thinking about this is that we are isolating the variable. In other words, we're getting the variable x or a or b or whatever it is all by itself, okay, on one side. Can be either side. Often you'll notice we have it on the left, but it can be either side for sure, okay, but all by itself. So x equals, and notice it's not 2x or it's not negative x. So negative x equals means I'm not done, okay, or it's not x over 15 or something like that. It's x all by itself. Now, this first lesson is all about one-step equations. So once we've done one step, that should be enough to solve it, and we should be done. But in the future, we'll have more than one step, so you have to remember to finish the question. All right, let's get into it. Solve each equation. And I said to you that we were going to talk about strategies that would work. And again, this might be a situation where you already know the answer, and that is useful because that means when we use the strategy, and we're going to start practicing the strategy now. So even if you can solve this on your own, you really need to try using this strategy, and it's better using it for questions that you already know the answer to, for easier questions, and get comfortable with the strategy, and then you'll have it nailed for when you need it when the questions get harder. Okay, so don't skip over using these strategies just because you can do the answer in your head. Try them. It's the best thing to do. It's like a sport. If you're practicing a new skill in a sport, like passing a puck, you don't do that during a game. You sometimes just stand across from a partner and pass the puck back and forth in a simple kind of situation. And that's kind of what we're going to be doing. We're introducing a simple situation and practicing a strategy so that we perfect that strategy and improve that strategy, that skill, for when we need it for harder questions. Okay, and the strategy is this. If I am adding 3, that's what's in the way of x being by itself. So somehow I need to get rid of this 3. And the nice thing about equations, when you have an equal sign and two sides, is you can kind of do whatever you want. But again, the rule is whatever you do to one side, you do the same to the other. So how can I eliminate that 3? Well, what if I subtract 3? Because positive 3 minus 3 will give me 0, and then that will be gone. And that's how I can get rid of the plus 3 on the left side. But if I'm subtracting 3 pounds from the left, I have to subtract 3 pounds from the right. And that ends up looking like this. Okay, and notice that 3 minus 3 is 0. So this is like x plus 0, but we don't have to write that. So we have x equals 15 minus 3, and x equals 12. Now, you can write this step if you like that. Some people like putting the negative 3 on both sides like that. You can do it this way, where we write the negative 3 on both sides, but we just write it sort of above. Okay, this is the method that I usually use. It's a little bit faster because you don't have to write out a whole extra line. And what I do is after I have written it out, I circle this side, and I sort of ask, does that give me 0? Did that actually get rid of the thing I was trying to get rid of? And in this case it did, so it's right. You do not have to write out that step, but you certainly do have to write out the final answer, okay? So you would only have to show this or this and then this. Okay, let's try another one. again, you can come up with the answer yourself, but we're going to try to use the strategy. So if I'm subtracting 1, what do I need to do to get rid of that? I'm going to add 1. Whatever I do to one side, I do the same to the other. What I like to do, as I said, is circle. And is 1 minus 1. Okay, I've got a positive 1 and a negative 1. Does that give me 0? Yes, it does. And there's times where we need to be careful where this will help. Okay, so you don't have to circle it every time if you're good at this and you are confident, but it's not a bad idea to think about it that way. Okay, so this means 5 plus 1 is x. So x equals 6. You don't have to write it both ways. I often do because this way of writing it, to me, makes more sense in terms of answering the actual question. Because it says x equals 6. So I kind of like that. So I often write it that way, or I'll just automatically write it the other way instead of writing it backwards like this, but it doesn't matter. Both ways are fine. So those first two questions, the first question was adding, second question was subtracting. This one's multiplying. 2 times something is 18. What is the opposite of multiplying? So this is the other way that you can think about it, is always doing opposites. In this case, we were thinking about what makes it 0. And if I had a negative 1, I need to add 1 to make it 0. Okay, whoops. But in this case, we're not making it 0. We're not subtracting 2 because we're multiplying. And 2x minus 2 doesn't give you 0, right? That doesn't make any sense. Those aren't like terms. You can't do that. So what do we do in this case? What's the opposite of multiplying? It's dividing. So we're going to divide by 2. So I've got 10 pounds on one side and I'm dividing it in half. I have to divide the other side in half as well to keep it balanced. It's not actually 10, it's 18, but I just mean, like, think of that example of the scale from before. So 2 divided by 2 is 1, so we've got 1x, which is what we want. 18 divided by 2 is 9. And this is where, if you can't do that kind of math in your head, your calculator will do it for you. And so what we've done is we've built a question that we can plug into our calculator. In fact, I'm going to write that out. X equals 18 divided by 2. So you definitely don't have to write out that step when you're doing this. But you can type that into your calculator. And again, 18 divided by 2 might be something that you can do in your head. But what if it was some kind of huge number and it wasn't just dividing by 2, it was dividing by something else? And what if it gave you a fraction answer or a decimal answer or something like that? And so those are the cases where, being able to build a question that you can type into your calculator is really, really useful. Okay, let's try to quickly go through some more. You can pause the video at any time to try these yourself. This is the same, where we're going to divide by 5. And divide by 5. $30 divided by 5 is 6. So that's all the different kinds. Now the rest we're going to do a bunch more examples, and again, I would encourage you to try them yourself. And in fact, if you've printed out the lesson, you can go and try all of them, and then you can check your answers online, or you can check your answers by watching the rest of the video. If you think you've got it and you want to try some on your own, you can pause the video now or stop the video now and go for it. But I am going to do a couple that are a little bit different and just talk about how they're different. And again, remind you of the strategies that you can use in order to also be successful solving these kinds of questions. But if you think that you're good, you can stop the video now. It's already been fairly long, so that's fine. Or just pause it and go try some, and then if you need to, come back and watch a few more of these questions to see if you can get the right answer, okay? Or just watch, if all you need to see is question G, then just skip to that part of the video and watch that part, right? You don't have to necessarily watch every one. That being said, I'm going to dive into this one. So this one, here's what people might think. If people are thinking you always do the opposite, and what am I doing here? I'm adding. What's the opposite of adding? Subtracting. So I'm going to subtract 7 and subtract 7. Okay, don't write this down, just watch for a minute. And A is 10 minus 7, which is 3. But here's where this circling thing comes into play. What is negative 7 minus 7? It is negative 14. It's supposed to be 0. So this didn't work. Okay? The whole point of this is that whatever I did didn't work. So whatever you're adding or subtracting on one side, and you have to do the same to the other side, has to give you 0, right? Inside this, it's got to give you 0. If I'm trying to get rid of this -7, whatever I do to it has to give me 0. And because it's a -7, I want to add 7. And this is a common mistake that people make. And whatever I do to one side, I do the same to the other, right? This is a common mistake because you look at the operation and you say you're adding, so I want to do the opposite, which is subtracting. But in this case, we're actually looking at that sign, not the sign between them. Okay, so again, we can write these questions in a slightly different way, and it really, really does make a difference. This question could be written like this. A minus 7 is 10. And then in that case, you might be like, oh, well, it's 17, because 17 minus 7 gives you 10. So that way is easier for us to answer just with our intuition. But when I write the -7 on the other side, all of a sudden it makes it harder. But now I've written it in a way that I can punch it into my calculator if I need to. In this case, I don't, and I can do that in my head. Okay, so I really do want you to take away from this lesson that it's great if you can solve these quickly in your head without doing any work. I still want you to write the answer properly. Okay, these one-step equations, you don't have to show any work. You don't even have to do this part. You can just write the answer. But they are going to get harder. Trust me, they are going to get to a point where you can't solve them in your head, and that's where you need a strategy, and so it's worthwhile practicing this strategy now. Remember this kind of a question from the beginning activity. 9 plus something gives us a smaller value. So plus what? And we talked about this, and some people might be able to do this, but we're going to use the strategy. So this is a positive 9. Okay, I'm not looking at this plus sign. I'm looking at the sign in front of it. It's a positive 9, so I'm going to subtract 9, and 9 minus 9 is 0. Whatever I do to one side, I do the same to the other. So y is 1 minus 9, which is -8. And that, again, that's an example of where the strategy works really nicely to solve questions that may not have obvious answers. Okay, we'll try a few more. Now I am adding 12, so I subtract 12. It's not because there's an adding sign between them, it's because the 12 is positive. That's the sign in front of the 12. Whatever I do to one side, I do the same to the other. Whoops. X is 3 minus 12. You do not have to write this line. I often will show extra lines in my lessons for people who are looking at it later, or because, I'm saying it out loud, but it can also help you to see it written on the page, not just hear it. And if you are copying what I'm writing, which you should copy down every step, not just say, oh, well, I like to do it this way, so I'm going to show it differently. No, you should be writing down the same way I do it. And then if you look back at your note or you look back at my note online, you'll realize that the -12 that's above the 3 means 3 minus 12, right? And 3 minus 12 gives us -8. I'm sorry, -9. I don't know where that came from. Okay, so I'm adding, but what I care about is this sign. So it's a -6, so to get rid of it and turn it into a 0, I want to add 6. So I do the same on both sides. -4 plus 6 is x. So x equals -4 plus 6, which is +2. Now, if you do it this way, that's fine. Like I said before, it doesn't matter. Sometimes I just write the answer like this and sort of skip that step. A common strategy that some teachers even teach In particular, I think in elementary school, but you'll notice that different teachers do these questions different ways, and it can be useful to see different ways of doing it, and you can pick your favorite and go with that. And some teachers teach that you take a -6, move it to the other side, and it becomes a +6. So it becomes -4 plus 6. And that's fine. That strategy works if that's what works for you. If you realize that that's what's happening and use that as a shortcut, that's okay. But don't confuse the strategies. So what some people might do is they might go, okay, I'll add 6 on this side, and on the other side I do the opposite. Whoa. No. I've added 6 pounds to one side and taken away 6 pounds from the other side. I have definitely put things out of balance. So you can't mix the strategies, right? So the strategy that I'm using is I'm showing what I am adding or subtracting or dividing or multiplying by on both sides. Okay? I'm not just moving something to the other side. So be a little bit careful of those. I think we only have a couple more left. Again, you can try these yourself. I'm subtracting 4, so to get rid of that and make it 0, I add 4, and I can circle those two things and ask myself, is that 0? And it sure is, so what I did was correct. So 7 plus 4, whoops, I started writing the answer there, is A. And again, you can use your calculator, or if you can do this in your head, A is 11. -9 plus something is 5. Again, if we were doing this question in the activity from before, we would just be trying to figure it out in our head, but we're going to use this strategy. So if I want to get rid of a -9, I have to add 9. Whatever I do to the left side, I do the same to the right. So n is 5 plus 9. N is 14. Now that might seem like a strange answer because it seems kind of big, but remember, we were starting in the negatives. If we go back to our number line, we were starting in the negatives. We were starting at -9, and we had to get all the way to 5. So we had to go 9 to get to 0, and then 5 more. So we added 9, and then we added 5, and that's why we're adding 14 total to get there. Okay, and you can always check these. Watch. So it's -9 plus 14. And that gives you 5. So the nice thing about these equations is that you can always check your answer by putting it back in and making sure that it does give you a balance sign. Looks like we have 2 more. Let me just check. Yeah, so 2 more. Something -9 is 0. This is one you probably can do in your head. Let's see how the strategy works. Add 9 so that I have 9 and -9, and that does give you 0. And 0 plus 9 is 9. So if you had the answer 9, that was right. 9 minus 9 gives you 0. And again, this is the last time I'll say this, it's great when you can do these in your head, but it is also great to have a strategy when the questions are harder, and to be able to sort of use both of those to have confidence in that strategy, to see how that strategy is working and make that connection is really, really powerful. Okay, last one. I'm adding 1, so I want to subtract 1. So I subtract 1, subtract 1 from the other side as well. So 0 minus 1 is A. 0 minus 1 is -1. So A equals -1. Okay, so that was a few different, we only did a couple that were multiplying. But make sure you understand that strategy as well. We did more that were adding and subtracting. These ones do tend to be a little bit trickier because, if you have those questions where the negative is on the wrong side, like J and a few others that we did, that can be confusing. So that's why we did a few extras of those. But again, in the Practice. Start using this strategy now and get familiar with it, get used to it, because when the questions get harder, you are going to need these kinds of strategies to solve these questions. Okay, good luck with the practice.